email them after you leave tonight's meeting. This is the way for you to get back in contact. And if you haven't paid, we'll also take your money for dinner. So now I'd like to introduce tonight's speaker, Dr. Samantha Rubright. I know it's standalone, so it's really confusing. She is a co-founder and communications expert for Fractracker, and she is going to be giving a presentation tonight about the work that they do studying, tracking, and monitoring the impacts of fracking across the U.S. She got her PhD recently from the University of Pittsburgh and her MPH, which is how I know her. We actually went to school together in Pittsburgh. And it's my pleasure to introduce her tonight.
All right. So thank you so much for inviting me here to speak, Sarah, and to the rest of the group and everyone for attending. This is my first in-person meeting, but I have participated through the webinars, which are really fantastic. Just to reiterate, my name is Samantha Rubright, and I'm the Manager of Communications and Partnerships at Fractracker Alliance. It's a nonprofit that I helped to launch in 2012 out of the University of Pittsburgh. Now, our mission is to study, map, and communicate the risks of oil and gas development. We're not an advocacy organization per se, but we do look at energy issues with a critical eye. On a more personal level, I really believe in the value of, and actually I would say the necessity of transparency. So it's a characteristic that not only I carry on through my work, but also it's something that's embedded within the organization as well. So the title of my talk was kind of comparing big tobacco with fracking. And just for a little bit of background, lung cancer was once a very rare disease. And I'm sure in a room full of this, you guys probably know more about big tobacco than I even do. But it was so rare that doctors took special notice when they were confronted with a case and thinking it was a once in a lifetime case that they would see. And then toward the end of the 19th century, a global lung cancer epidemic developed at the same time as mass marketing and mass production of cigarettes. Now, it was eventually recognized that smoking was contributing to these lung diseases, but not until the 1940s and 50s. Cigarette manufacturers disputed this evidence as part of actually an orchestrated conspiracy to salvage their cigarette sales. This propaganda was successful since oh wow, we're gonna start this one over again. Absolutely. So essentially, it took a really long time for us to prove that cigarette smoking was linked to these lung diseases. And it's showcased by the fact that even today we still have people who are smoking, on top of the fact that it's addictive. But now on to the topic of fracking. I'd like to assume that most of the people in this room have at least heard of fracking as it relates to oil and gas. Is that true? Is this not a word? Okay, all right. Today I'm really going to provide an overview of what we know about the industry's extraction process, some of the potential health and environmental impacts, and actually on a more personal level, why working on this issue has been extremely trying, similar to, I assume, to how people who were working on the health links between tobacco use and lung cancer. Now, before I get into that, I wanted to sort of overlay why I thought that quote-unquote fracking, what we think of as fracking, the public, why we think I think it's a one health issue. Domestic oil and gas production has benefits, economic and otherwise, and I'd say also much more than tobacco, but there are also many risks. And unfortunately, these risks are not shared equally by those of us who actually rely on natural gas and oil and their byproducts in our everyday lives. There are many ways in which people, animals, and the environment may be affected by all of the processes involved in oil and gas extraction. And the pathways are very complex and poorly understood. Now you take all of that and you add on the fact that it's an extremely controversial subject. Just the other day, an oil and gas lobby group asked Google to label all anti-fracking websites as fake news. So that's a kind of environment that researchers like us and groups like ours are working in right now. General outline, it's always good to know what you're getting into. So first I'm going to start off with the unconventional drilling process. How is that different from what you think of your grandfathers, what was the olden time of how we used to extract oil and gas? So the days of just drilling straight down into the ground and accessing a pocket of hydrocarbons, whether that's oil or gas or sometimes both, those days are gone. In the US and across most of the globe, drillers have tapped those easy-to-access resources, so now they have to utilize more unconventional drilling techniques for extracting those hydrocarbons. And I'll give just a very quick, brief overview of what it all involves. So first, you have to find where the reserves are located, and in some cases that utilizes seismic testing. Then as a company, you have to obtain leases and permits to drill in that area. Now sometimes the leases will be obtained by the people who own the mineral rights below the land. These can be separate from the people who own the land rights where the drilling will occur. And this is important when you talk about the economic versus the sort of negative sides. If you have to live above or near a drilling site but you're not getting any money from leasing out your mineral rights. Then you have to, once all of these permits and leases have been secured, you have to prepare the site. And this is where I'll show you some of the photos of the well pads. You have to flatten it so that you can actually operate safely. There can be several wells on one well pad. Some sites can be as big as 40 acres. Some of them are much smaller depending on where you're drilling. Then you have to haul in all of the components that are needed to drill the well. And then you prepare the frac fluid, the fracturing fluid on site. And I'll discuss that in a bit more detail later on. Now this is a really basic infographic. I actually created this for Chesapeake PSR, but it kind of gives you a general idea of the fact that there are a lot of processes involved going on at different times so that the time frames differ, and there's a lot of people involved, contractors and otherwise. So once you actually then begin to drill the well, you first have to drill down vertically. It's very, very deep. This is below the water table. And you're drilling into a formation of interest. In this case, it's shale. And these are essentially old ocean beds that have hydrocarbons trapped in very small pores within the rock. Then what they figured out, instead of going down vertically and poking small holes into all of the places where you want to extract the gas or oil, that it was more viable to turn the well horizontally and follow the formation. And you can actually obtain oil and gas at the same time, and depends on the formation. But typically you're either trying to access gas or oil, but then you'll also get other hydrocarbons. Once this horizontal well is drilled, they pump down a significant amount of fluid into the well, and they will actually fracture the rock so that the small pores become big pores and that it can be brought into the well. And this is called well stimulation or hydraulic fracturing. So that is where, as the public, we understand what fracking, we think of fracking as this entire diagram and more. Whereas companies, drillers are going to say, no, fracking is only that small section under the ground that we're talking about. And that's important when you talk about PR, when you see people saying, well, there's never been a documented case where fracking has contaminated drinking water. Well, yeah, if you're only talking about that small component, that may be true for your company. But it's much broader than that. If you're living near these wells, you aren't thinking of just that small stimulation of the well. You're thinking of the spills on site. You're thinking of all the fracking chemicals that have to be mixed on site and what they're volatilizing. There are two ways generally to stimulate a well. It all involves high pressure generally. In the Northeast, in most parts of the US, it's a lot of water and chemicals that build up and create pressure. In California, however, the geologic formation is a little different, and they use a process called acidizing, which literally dissolves the rock using high amounts of acid within the fracturing fluid. So now you have this pressure ball down in the ground that it wants to come back up the well. So once they release the pressure at the top of the well, this flow back, this produced fluid, returns back up the well. And this is actually when you have to separate natural gas from all of the other hydrocarbons and the constituents of the fracking fluid that you originally injected. Now, waste is originally stored on site in either storage tanks or impoundments, and I'll talk a little bit about some of the risk factors there later. So instead of an infographic, I thought you might like to see what it actually looks like in person. You can see that they had to flatten out where the hillside comes down on the right. This is the rig itself for, I believe this is actually the hydraulic fracturing occurring. I could be wrong, but it's hard to tell there. But there's also a lot of construction equipment and trucks. This is a relatively small well pad. It's located in an extremely rural area in West Virginia. There are storage tanks for what comes back out of the well and condensate tanks. Those are some of the tanks that you can see on the right. Now, after you get away from the well pad, fracking is actually part of a much larger, intricate system. You have sand that is required. Sand is something that goes into the fracturing fluid. It's used to prop open those small cracks that were created when you fractured the rock. So you have to mine that sand. And there's a lot of that going on in the Midwest right now. And that sand is called propant. It literally props open the rock. You have a lot of diesel trucks required to haul equipment and supplies to and from the well pad. You also have the need to store some of the returns and the chemicals that are used for the fracturing process. You have flaring. No, I did not intentionally make that look like a cigarette on that's lit, but flaring occurs when the returns are coming back up the well and they need to test it for viability. And sometimes it's also for safety to release pressure on the well. Then you have to get the products to processing facilities and the market via pipelines. And this is actually done through what are called compressor stations. They separate the gas and will push it into pipelines. And finally, you have processing plants and terminals used to complete the distribution chain to customers and also to ship it overseas. There is not really one set of federal regulations that oversee the unconventional oil and gas industry. Most oversight occurs at the state level, and in some cases there are exemptions from federal regulations such as the Clean Water Act, the Safe Drinking Water Act, the Clean Water Act, and CERCLA, or also known as Superfund. These exemptions occurred in 2005 in the Federal Energy Appropriations Bill. And here are some just photos that from our group that show you what the pipelines look like. They can be varying sizes. The compressor station on the right and the larger processing facilities, because you're not just getting oil and natural gas, you're also getting ethane and pentane and butane, and these are very valuable on the petrochemical market. So a little bit more of what we do at Fractracker. As you can assume, we track fracking. Yeah, it's a pretty original name. But what we want to do is show people, okay, where is this drilling occurring? Where are these activities? Who's at risk? What are the population densities near some of this activity? And in 2016, we finished up an analysis looking at data from 2014 to 2016. And I'll let you know, this data is not available to the public at a federal level. So we had to go to every state that has drilling activity, request or obtain their data of where wells are drilled, and process it manually. We are a small nonprofit of 8 people with a much smaller budget than probably is appropriate. So you can imagine this could be done a lot better with more funding and more people, or by a government agency. But it's a lot of work to get this information together. But what we found was that there are 12.4 million people in the U.S. living within a half mile of production wells, natural gas compressor stations, and processing plants. And these are just the active ones. These aren't the old ones. These aren't the previous ones from years before. And that equates to about 1.2 million active sites. It does not account for the other various processes that I included on the infographic, such as pipelines, and some of the petrochemical facilities. So infographics are great because that means I don't have to include or write a lot, but this one is from PSE Healthy Energy. It's a nonprofit that is combined of physicians, scientists, and engineers. In 2016, the directors published a study in PLOS ONE that attempted to look at the broad literature around what we know about the health impacts of fracking, the entire process of fracking, not just the stimulation of the well. They found 685 papers published since 2009 up until 2015, and there were practically no studies in the literature prior to that time. Most of the studies contain findings that indicate air quality issues, that's 87%, health issues, and then water quality. And I'm going to kind of use these categories as a guide for the next couple of sections of my presentation. So I'm going to start first with health. So this is, I borrowed this from a colleague, Dr. Lisa McKenzie, who gave a talk in April of 2017, but I liked the way it sort of showed where the potential sources of exposure can be based on proximity to the well site. And it kind of, you start with drill cuttings, you have accidents on the site, and then you expand to more of the local area. So you have traffic, you have water quality and water quantity concerns. You also have diesel exhaust. Out into the regional levels, you're talking about ozone precursors, and globally, more of the climate change and the impacts from methane. And like I would say, in contrast to smoking, fracking has so many different potential sources, and that's one of the reasons that this research is so difficult, because we're not just talking about, you know, somebody actually smoking themselves or second or third-hand exposure to cigarette smoke. We're talking about all these different processes, different timelines, and it makes it extremely difficult to track, but it is something I think that is worth doing. So here's what we know based on published predictive and descriptive health studies, and it really makes a lot of sense. People living nearest to the well pads may be at increased risk for neurological, developmental, endocrine system, and respiratory health effects, as well as cancer and stress. And stress was one of the first areas that we started looking at research at the University of Pittsburgh, because we were getting some frantic calls, and we realized that stress was also exacerbating some of the other exposures that they were being presented with. Risk for exposure and health effects is greatest during a period of short-term but high air emissions that may occur during events such as well completions. That's nearing the end of the drilling process where they're closing up the well and testing it. They also might be higher at night, and there are some really interesting research questions surrounding why that may be the case. There are also some studies linking well density to a variety of other health effects, such as bladder and thyroid cancers, early infant mortality, and cardiology and neurology hospitalizations. Now, studies on the effects of oil and gas production have found also increased risk, especially for wildlife. And I was listening to everybody's background in the room here. We have a lot of veterinarians. Animals and wildlife and livestock were actually one of the first areas where people started to see impacts, because the wildlife could fly down to an impoundment and drink out of it. The deer really liked the impoundments before they were protected by fences because of the salt. If you know anything, like, I'm from deer country, and the salt licks are fantastic for deer. Livestock were dying, or they were having trouble reproducing. And that's still been an issue in some parts of the country. It's not quite as bad as it used to be, I would say, but there's really very little research. A handful of studies looking at some of these impacts. So I think that's a major research gap that we could use some help with. One of the more disconcerting aspects of publishing studies in this realm right now is that if your study shines a poor light on the oil and gas industry, there's a lot of money and a lot of people who will try to question that, will drag your name through the mud, will try to make you look like you have an agenda. And in some cases people do, because if you publish a study that says that there are no effects from drilling to this certain population that you studied, you get attacked from the other side. So as I said, it's a very controversial subject. It's difficult to work in. Right, so we're going on next. What I can more concretely tell you is that oil and gas well pads and its infrastructure pose significant risks to workers. From 2003, well, I'd say actually if you just look at 2007 to 2011, there were 529 fatal injuries from workers alone. This is not including any residents who might have been affected. And because of this rate of injuries and deaths, OSHA decided that this was going to be categorized as a high hazard in their severe violator enforcement program. Some of the major risks on site are physical hazards, getting your hand caught in one of these very tight well pads. This is a photo of fracking and silica sand mixing going on at the time. So there is silica dust exposure. And some of the research that was done a couple of years ago by NIOSH, I believe, they found that silica dust was one of the higher risks for these workers because the workers didn't realize that it was a very dangerous thing to be breathing in. They weren't wearing proper respiratory protection. That has since changed, but it's one example of sort of the industry and things moving a lot faster than the health studies and the research could follow up with. And in some places, hydrogen sulfide is also a risk. It can come out of the well because you're talking about hydrocarbons that have been cooking down in the ground for a long time. Hydrogen sulfide can also come up the well and be part of the returns and is also a hazard on site for workers. All right. So accidents, these things happen. This is drilling mud. This happened in West Virginia. This is not an isolated event. You have a lot of truck traffic. You have people with deadlines, and they're moving fast, and unfortunately, truck accidents happen. And again, this is a very dangerous industry. So well explosions, you're working with a lot of volatile compounds. Something just goes wrong, you have a little bit of friction, and the well pad can explode. Parts of the well pad can explode, and all the chemicals can catch fire. But really the question when you talk about accidents and violations is, what is the rate? How often are these kinds of incidents happening? Are they rare? At a national level, it is impossible to tell with the available public data. One, because some of that, first of all, that information is often not made public. And only a few states actively collect and share that information. I know of 4, there might be 5 or 6 out of the 36 that have active drilling. And there might be cases where you can find a data set from 2002 or a data set from 2009. But the actual public transparency of violation data is very difficult to come by. Now, I have an example on this slide from Pennsylvania because that is an example of one of the states that's doing it a little bit better than most. They release violations, so these are violations that the state recognizes and caught of the drillers. So since drilling really ramped up in Pennsylvania, I'd say since 2002, but probably more likely 2006, there have been 18,000 wells permitted, 10,000 wells drilled, and about 6,000 violations issued. Now, typically, you're talking about bad actors. And usually, you're looking at something, there's one well with 5 violations. Not every well has a violation. And violations can vary from you didn't fill out the right paperwork, but that could also pose an environmental health risk. Or it could be that you had a worker incident on site that should have been prevented. It's very difficult with the available data, even from Pennsylvania, which I consider to be pretty good, to flesh out, okay, is it health and safety violations or is it paperwork violations? You would have to go through every inspector's notes, handwritten notes, to determine that. And so this is kind of the data transparency issue that I'm hitting on here. It's really difficult for us to understand what are the risks to workers and to the public when we can't get access to very good data about it. Something we do have good data on is pipeline incidents, and that's partially because when a pipeline fails or something goes wrong, it's a lot more obvious. Many miles of pipeline have been added to accommodate this domestic rush to drill for oil and gas in the U.S. But with that growth comes problems, unfortunately. Since 2010, there have been over 4,000 pipeline incidents, resulting in 100 reported fatalities, 470 injuries, and property damage exceeding $3.4 billion. And this is according to the Pipeline and Hazardous Materials Safety Administration. Recent issues put that rate, so you're talking the last couple of years, at 1.7 incidents per day for pipelines. And typically when you're looking at those incidents, it's from equipment failures and corrosion. And as we have this aging infrastructure of pipelines, I feel like we're going to see more and more of that as we go on. So now I'm going to kind of get into the water and waste issues. Early on, the conversation around what these risk factors, what was most problematic for residents was water. People wanted to know, is this going to contaminate my drinking water? And that's partially because they're using this chemical mixture, frac fluid, where it's 99% water and sand and 1% chemicals. But if you're looking at a well that for one hydraulic fracturing job requires 5 million gallons of fresh water, that's still a lot of amount of chemicals going onto site, the risks of spills and things like that. So for example, a 4 million gallon fracturing operation would require between, some of the literature says 80 to 310 tons of chemicals. And that each well can be fractured multiple times, and you can have multiple wells on each well pad. So it kind of grows out after that. And like the chemicals found in cigarette smoke, many fracturing fluids are known to be toxic to humans and wildlife. Several are known to cause cancer. Some of them are also, let me go back here. Potentially toxic substances include petroleum distillates such as kerosene, polycyclic aromatic hydrocarbons, formaldehyde, ethylene glycol, hydrochloric acid, sodium hydroxide. And these chemicals are used in the well to prevent bacteria growth because you have a lot of pressure, a lot of temperature, and if you allow this bacteria to grow, it'll clog up your well. Some of the chemicals used in this process are endocrine disrupting compounds, so you don't even need to be exposed to very high levels of these compounds because of the way the endocrine disrupting compounds work at such low levels. The mixtures will vary by region and company, and some of the chemicals themselves are proprietary. So here again are some more data gaps that we're talking about. Between the years, let's see if I'm on the right slide here. So essentially, groundwater contamination can occur. Between 2009 and 2015, fracking and its related operations have been associated with ground and surface water contamination in the majority of published studies. In 2016, and we have some EPA folks here. I'm not trying to bash you because my husband works with the EPA too. So, but the EPA did confirm that there were numerous instances of drinking water contamination from spills of fracking fluids, discharge of treated wastewater, and below-ground movement of fluids used in the extraction process. It got some negative PR the way it was put out, but those were some of the major findings in the report. The report also suggests that water contamination can and does occur during routine activities. It doesn't necessarily have to be a well gone wrong. And essentially what this means is that it's part of doing business. In Pennsylvania alone, there were 256 cases of private drinking water contamination from unconventional oil and gas drilling confirmed by the state as of March 2015. Now, most of these determinations were because of methane migration, but there were also some chemicals that were part of the fracturing fluid that migrated too, and this usually happens because of poor well integrity when you're going down through the drinking water aquifer. There's still much to be learned about the migration process and how and why these gases and liquids migrate into private drinking water. That's one of the research areas I would really love to see more dollars go into. So these are just some examples of what we've collected. On the left is a spill into a nearby stream. On the right, the landowner seeing water substances bubbling up from the ground. And the driller was later cited for putting a well pad on top of a wetland. It doesn't sound like the best of ideas, but especially when you're talking about poorly aligned well pads. And this was in West Virginia, and this was a couple of years ago, so the standards have definitely improved, but we are still seeing incidents like this. Now, as our understanding of some of the risks developed as researchers, we began to realize that what was going into the well was not nearly as important as what was coming out. In addition to the chemicals used during the drilling process, the wastewater picks up components of the rock, of the shale formation itself. And these components can include arsenic, hydrogen sulfide, low levels of naturally occurring radioactive elements. It's also very salty, as I mentioned, so that presents an issue with cleaning the wastewater. That's actually the primary signature of wastewater, is that the high concentration of total dissolved solids. One of the interesting things, and it is because it depends on where people are drilling, but the wastewater signature is going to vary pretty greatly from region to region and even operator to operator. So it's also very hard to track whether wastewater or the associated process is impacting some drinking water source because of the variety of the variation within that wastewater. I mentioned the composition because it affects how it can be regulated, how it can be stored on site, and how it's disposed of. On site, you can have recycling. So what that means is that they let the total dissolved solids kind of settle to the bottom, and they'll reuse some of this water in another fracturing operation on site. This is preferred. I mean, this means you're not using as much fresh water. You're not using as many chemicals even. Eventually, however, that water has to be processed. It has to be cleaned at some point. One of the ways that the wastewater is stored are these open impoundments, and I'll show you a photo of it. These are not ideal for a number of factors. The liners are known to leak, and you can also have wildlife that can come in and be exposed to it. It also volatilizes, so you get some of the BTEX compounds going into the air. Closed containers are certainly better, especially if you're operating in floodplains, and that was something that operators from Texas, when they moved to Pennsylvania, they realized very quickly that they needed to be careful about how they were storing their waste, because in Texas you don't necessarily have the same kind of flooding issues as you do in Pennsylvania. Off-site, there are recycling facilities that have started to be built. It's not as common as it should be. Reverse osmosis and distillation processes are not likely to be used just because it's very salty. There's a lot of chemicals. It would just be too expensive from the bottom line of industry to use those processes. There are centralized weight treatment facilities that are starting to be built. There are some in Pennsylvania, for example, that can treat the wastewater. The solids are typically taken to landfills. So these are the drilling muds. It's the compact what settles from the liquid waste. There have been some issues, however, with landfills, especially in West Virginia, of seeing spikes in their radiation monitors, because you're essentially condensing all of these T-norms and putting them into the waste that's being sent. So they have to be very careful, too, about how much waste they're receiving from the oil and gas industry. Beneficial reuse is something that is a category in some states, and this is what they'll do is they'll take the brine, the salty wastewater, and they'll apply it to roadways for dust and ice control. And you can imagine that's pretty problematic based on what I said within the wastewater. Now, Class 2 injection wells, these are federally regulated. These are very deep wells designed to dispose of oil and gas waste. They're typically considered to be the best option for long-term disposal. And on-site, you can also, some states will allow encapsulation, which essentially means you take the solid waste and bury it. So this is an open impoundment that was in West Virginia that I visited. I could only stand there a few minutes before I got kind of nauseous, but it's massive. It has to be able to store the produced water, the flowback that comes out of the well, for a long period of time before it's transported off-site. So I mentioned that deep well, Class 2 deep well injection sites are typically considered one of the preferred options for disposal. However, in some states, we're starting to see an increase in induced earthquakes. as a result of this activity. We have a lot of Class 2 disposal wells in the United States, over 30,000, but some of them have been giving us trouble because we have such an increase in the amount of wastewater that needs to be disposed of. Parts of Oklahoma have seen major increases in what we call induced earthquakes, and what that means is the conditions were prime for an earthquake to occur, but they needed that high pressure injection of the wastewater to sort of cause the fault to slip. And so it's not that we are causing, that the industry causes earthquakes, but that you're inducing them is essentially the terminology from that. And this has been documented in Oklahoma, Texas, Colorado, New Mexico, Arkansas, Ohio, and now there's more research even being presented that says that the actual hydraulic fracturing process itself may also induce earthquakes. And this happened in my home state in Pennsylvania. Okay, so I'm a Debbie Downer, right? I'm going to bring this up. So we're getting into air quality now. And I could talk about air quality as its own presentation, but I'm not going to, because you can kind of see that there are a ton of compounds that come back up the well that need to be addressed. You have particulate matter, hydrogen sulfide, ozone precursors, carbon monoxide, etc., etc. And this study looked at where those components were found and some of the potential sources on site. So is it from the vehicles that are being brought in? And if that's the case, can you switch over to a natural gas powered vehicle to reduce some of the diesel emissions? That kind of makes sense. Flaring is also a source for some of these air pollutants. There are what is called green completions, where you don't have some of this kind of air pollution happening, but for the majority of small operators and that for the older operations, you're not going to be able to see. You're going to see flaring. You're going to see open impoundments in some cases. What this study, so Brown and his colleagues in 2015, what they found was it's not necessarily that the regional air pollution was being severely impacted by this one well. What they're seeing is that there are very high peaks at certain times of the day in certain operations that are causing people to get nauseous. They're causing rashes, asthma exacerbation. It's the peaks that are problematic for some of these areas, especially if you have a lot of wells in one place, or you have a compressor station that is emitting a lot of pollutants. Another study looked at methane out of a compressor station, and I mean, methane is product. It is something that is valuable to the industry, so you would think that the methane would be the last thing that you escape from the natural gas side of things. But they were finding that it was doing some it was exacerbating asthma in certain areas. So it was pain that was published in 2017. But when they averaged it out across the 8-hour workday, obviously those peaks flattened out, and the emissions from those sites became within the regulatory standards. So industry kind of went and said, see, look, we're complying, we're in compliance. But that doesn't mean that there weren't health and effects down the road from these operations. So it's a tricky one to deal with, because we're talking about an 8-hour workday versus somebody who lives or has children in those areas. This is just one example of some of the air quality issues. This is, I believe this is also in West Virginia. And I could walk you through all of the diesel engines that are used to force the fracturing fluid down into the ground. You need a lot of horsepower for that. And so that's where typically a lot of the diesel engine issues come from the site. One of the issues, I mentioned the silica dust for workers. One of the research areas that really hasn't been studied much is how silica dust can affect residents near sand mining operations. For those of you who are close enough, here I'll use my cursor. So this is a frac sand mine, and typically the frac sand that they're seeking is very cylindrical. It's uniform in shape. That's why certain mines are preferable over others. And this is somebody's farm right here in the middle of it. And we haven't done any studies looking at the long-term risk for people who have to live near silica sand mining operations. We do know, however, that the amount of land that is being expanded and used for the silica mining process is very significant, as is water use. Methane has the potential to leak during every stage of natural gas production. I saw recently that at least on federal lands, the bill preventing methane from these sites was not removed from Congress the other day. Estimates vary widely on fugitive methane amounts from unconventional drilling. I mean, I've seen everything from 7, well, I don't even know if I'm not going to even mention numbers because it is so varied. There also is the fact, so you have methane from the actual natural gas production, from the transportation, but then you also have, most people follow the Aliso Canyon natural gas storage leak that happened, I think it was in 2015 and 2016. Let me see if I can get the numbers for that. In a matter of 5 months, it leaked 97,000 metric tons of methane, and it's because the site was not prepared to store the natural gas. Its infrastructure was failing, and it didn't get, the site requested help to fix this infrastructure, but they didn't receive it, so then all of a sudden they had a major methane release from the storage facility. Additional Aliso Canyon leaks are pretty much inevitable given the thousands of gas storage sites across the country, and a lot of them are aging. I have a colleague from Harvard that is doing research on where those sites are located and what ones are the most vulnerable. Okay, so we've kind of covered the health, the water, the air. What about, and the health is partially people, but what about what is happening to people who live near these sites? Most immediately, what people see is that truck traffic increases substantially in the area where drilling is going to begin. Some estimates say about 550 truck trips per well. I think that's a little low. The noise, the smells, dust, congestion, all of that can have significant effects on how community feels, and also the health of the community. And these roads, a lot of them were not designed to handle large trucks, long trucks like this. This is one of many photos that a colleague of mine has collected over the years of a pipeline truck going off the road. And you also have impacts to the community's infrastructure. The roadways weren't designed, you have accidents, and so you have impacts to the actual infrastructure itself as well. Drilling, whenever the actual well pad is going on, occurs 24/7, and this is someone's home right here. Drilling can occur pretty close to homes, so imagine trying to sleep through that. It sounds like a jet engine. I had one near my grandma's house, and it literally sounded like a jet engine going off by our home. Drilling can also produce not only noise and the light, but the noxious odors from all of the different compounds, the impoundments. If it's a warm day and you know, you've got this well pad up on a hill, some of the fumes can come down that hill and engulf the home. And as is the case with all, you know, all areas of industry have positive and negatives. I'm not going to dispute any of the potential economic impacts. That's not my role here today. We have seen job creation, but we've also seen job loss when the industry kind of, you see a fallback where the natural gas prices are too low, so they stop drilling. You also can have income to the people who own the mineral rights below the land, and revenues for state and local governments, especially governments that are prepared for that drilling activity and know how to properly manage it. On the negative side, if you live near one of those sites, you can imagine your property value doesn't stay high, and that's problematic if you don't own the minerals that are being extracted and you're not making any money from that. Also, there's a lot of people that have to come into an area to do work on these sites, and so the rental market, the housing has to accommodate that. In my hometown, there was one bed and breakfast that I can think of, and it was rented out overnight. So then you have issues with increases in rental housing costs for other homes and areas. So what that does is that pushes out the economically marginalized people to worse housing or to other areas. And then you might also see losses in non-related industries such as tourism or you know, national resource areas like hiking. And as I mentioned, drilling can occur very close to people, and I think that's one of the major stressors, is that they have to look at this from their homes. So this is a home on the left with a well pad right behind it. This is a school on the right with a well pad right behind it. Some of the schools are using it for revenue, and some of the schools don't own the mineral rights on their properties, so they have drilling without much say. Okay, so this is some of the more personal things. So I think these are the data research gaps that I mentioned throughout. There's a lot of problems with transparency. We don't understand some of the endocrine disrupting compound effects. What's the potential for a very large earthquake to be induced? Typically these earthquakes have been 3.0 to 5. They haven't been some of the larger magnitude earthquakes, but what's the potential for one of those larger ones? How are these compounds migrating in the ground? What are the effects on silica sand mining, the resonance near some of those mining operations? So obviously there's a lot of work to still be done. I certainly don't have all the answers myself. But those research gaps are extremely hard to fill when it's almost impossible to get close to these sites to do research. The photos that you saw are of people, the photos that I showed are people who were not receiving mineral right royalties, so they were very upset that drilling was occurring on their property, and they have access to those sites because it's their property. So they would let us go to those areas and do research and to take photos. But access to sites typically is very limited. And there's not a lot of federal, well, certainly not a lot of interest right now at the federal level to fund this kind of work. And on top of that, the oil and gas industry, especially lobbyists, have a lot of money at their disposal to attempt to discredit researchers and advocates. So this is a great example. This is, again, my home state of Pennsylvania on the Turnpike. This is a billboard that was taken out to sort of attack people who are questioning the fossil fuel industry. I personally have been the result of an online smear campaign, just kind of taking my presentation, putting it online, and saying, here's all the places where Sam was wrong. And early on, I'm sure I was, because we didn't know a lot. We were still working through things. I've been followed by oil and gas company workers when I was out in doing the field, and as a woman by myself, that was really scary, and obviously nothing came of it, but it was intimidation from the sense. I've been the victim of vehicular intimidation. A guy tailed me for 10 miles after giving a presentation in West Virginia. So there are pressures on both sides. There are environmental advocates, there are industry advocates who are very heated, and that makes this kind of research all the more important, but also all the more difficult. So in conclusion, there are definitely health risks, there are definitely environmental impacts, but we need a lot more research, and we need more structured research. It's extremely, as everybody in this room knows, it's very difficult to do work on something where you haven't identified all the sources, you haven't identified all the exposed populations. The time frame changes all the time. You have drilling one day and fracking the next, and then completion a few weeks later. I also think one of the major areas we could use some significant improvement is within the oil and gas companies themselves and government, so pretty much the state regulatory agencies, having more resources to make data transparent, to provide it to the public so that it can be questioned, can be mapped, it can be researched, so that reporters can go and do some kind of investigation based on good available data. And this is one of the major downsides right now, especially given the environment at the federal level focused on pushing fossil fuels and oil and gas. And I think when we see this pushback from industry, the similarities between big tobacco, to me, seem very real. And I think the fact that you have all of these inherent risks and you have all of this power and a lot of money and resources being put, it really makes this issue all the more necessary to have attention and possibly more regulation around it. So this is about Fractracker, but I would love to take questions. I can also stick around for a couple minutes afterwards and hang out. I'm definitely going to finish my beer. So if you have any, I would love to take them now or later.
Have you looked at reported cases of things like
Yes, so there have been studies that looked at birth defects, low birth weight, early infant mortality. I would say they are at the very beginning stages. They're typically based in a very specific region, so they're not generalizable to other areas. So there have been some in Colorado, for example, and some in Pennsylvania, but because the processes and the operators differ so much, it's extremely hard to apply that to other areas. There is a lot more work being done in that arena. I think it's one of the areas where we're going to see a lot more research. Actually, I know more research is going to be coming out of Geisinger Health System in Pennsylvania pretty soon. Go ahead. Yep.
So I presume right now one of the limitations on fracking is just the price, right? They're getting for the gas and the. So if prices went back to where they were a few years ago, essentially, how far would just fracking spread realistically, like across the U.S.? Like right now, there are very specific areas.
Well, the reason there are specific areas is because that is where old seabeds are located. So you really only have certain regions of the U.S. that are ever going to see fracking. Right now, the majority of fracking is occurring in the hydrocarbon deposits that are the most rich. Eventually, if the natural gas price goes up, and we are actually already starting to see that occur in parts of Ohio. You're starting to see drillers expand to the edge of that formation where there aren't as many hydrocarbons to be accessed, and it's much more resource intensive. So instead of 5 million gallons for what is being obtained from this well, we're talking 40 million gallons in parts of Michigan. So with higher prices, you're going to see drilling kind of expand to those edges. With lower prices, you're going to see the smaller companies being bought out by the larger ones because they can't keep up with the production at the rate that they need to for that price. And eventually, as the hydrocarbon deposits get depleted, we'll start to see the smaller companies buy back into the big companies and access those peripheral regions that are not as financially viable for the large companies, but maybe the smaller companies might be able to make a go at it. It's going to depend on a lot of things. It's going to depend on how much solar, wind, renewable capacity is brought online in the next couple of years. I think it's also going to depend on our ability to store energy in the battery systems. Right now, that's one of the limiting factors with renewables, is our ability to store the renewable energy. So I think it's a hard question to answer. I hope I gave you a little bit of information as to where I think it might go, but it is dependent on a lot of things. Oh, go ahead.
So I know you mentioned that there's no real nationwide regulations, and states are also a little iffy. I mean, I'm from southern Kansas, and my family talks about the earthquakes that woke them up in the middle of the night and all these things that I never experienced in my many years in Kansas. And so is there any way, it's one thing when it's in one state, but if something is crossing northern Oklahoma, has the fracking, southern Kansas is getting side effects. I mean, how is there a way to bring that capability?
That's a good question. So because of the variability, I think we're not likely gonna see a lot of cross-state or sort of regulations like that. There should be some bonding requirements put in place by the states where drilling is occurring or where the injection is occurring that could help address some of the financial damages that occur. I also think we could take away the exemptions from industry at the federal level for disclosure of, through CERCLA, through the Clean Water Act, through the Clean Air Act. Those are areas that could easily be filled. It's something we're going to see a ton of pushback. I can see that happening right away, but that's one area I think would help. So New York State banned hydraulic fracturing and associated processes, but they're still accepting the waste that comes out of Pennsylvania. So they're dealing with that question right now very much, and there's been even pushback now to try and regulate that and prevent some of it. So it can happen on a state level. Probably what you'll see is the pushback and saying, no, we don't want the waste here. No, we don't want this pipeline to be drilled or to be installed through our state or through this region. That's where we're seeing some control being enacted. Okay.
Fractracker has been very helpful to us in Maryland, where we worked on a fracking ban successfully. But a few comments I'll make in addition to what you said. In Maryland, what the industry fought tooth and nail against, and kind of was their own undoing, was they fought tooth and nail against any monitoring prior to drilling.
Mm-hmm.
So they put a tremendous amount of energy into, in cost and money and lobbying, into saying we should not need to monitor water quality or air quality prior to drilling or after drilling. And that goes to the fact that there's a concerted effort not to gather data. The other thing they put a tremendous amount of effort into was making sure that medical professionals and health professionals did not have access to information. So the state medical societies and the Maryland State Academy of Pediatrics had put forward legislation which would have allowed health professionals access to certain information, and they came out in full force fighting that. Not only the oil and gas industry, but the agriculture industry and the chemical industry. And so I think in Maryland they really showed that they were not good partners, they were not good people to work with, and the state just said, you know, this is not something for our state. I would also say that there's a big push to export. There's very few or any exports right now, but there's a big push to export. This is a global market, it's a global commodity, and as exports happen, prices will rise because they're more expensive overseas. And then you'll start to see pressure for drilling in areas that there's not pressure now. So just in Maryland and right around DC, there's gas basins up through Leesburg, Montgomery County, up to Gettysburg. There's gas basins in Prince George's County down south into Virginia, and there's gas basins on the eastern shore. They're not economical now. Who knows the situation in 10 or 20 years.
Mm-hmm.
So the technology is great. It's an amazing technology, but it creates a tremendous number of health problems that we really don't understand yet.
Absolutely.
So just
No.
a comment.
Thank you. Other questions?
Awesome.
All right.
Already 8:30, so I think
Sorry
that's
for talking about it.
You started late. So as a token of our appreciation for every one of our speakers, we have a flag for you. It's a certificate, and the flag actually flew over the Capitol building.
Oh, no way.
So,
Oh, my goodness.
give her one more round of applause.
Buy this on Amazon?
And before we wrap up, just a few housekeeping notes. Please throw out your trash and take your glasses back to the bar if you can. And stick around as long as you want. We can network a little.
There's also some food left, so if you didn't get full, we still have a good amount of food left.
There's a lot of rice.
And federal veterinarians,
It's a hard issue. There's so many assets.